Welcome to Module 8. In the final module of this course, we will cover some important security and privacy considerations for data engineers. In this module, we will start by introducing some fundamental privacy concepts that are important for data engineers. First, let's start with the definition of data privacy. How do we define that precisely? Data privacy refers to the proper handling of sensitive data, ensuring that it is collected, stored, and shared in ways that protect individuals' personal information. Data engineers must be familiar with privacy regulations such as the General Data Protection Regulation in Europe and the California Consumer Privacy Act in the United States. These laws dictate how personal data should be processed and stored, granting individuals rights over their data, such as the right to access, correct, or delete their information. To address data privacy in data engineering, we will cover the following concepts: data masking, data minimization, anonymization and pseudonymization, encryption, and access controls. All these concepts apply to safeguarding data privacy in any data environment, regardless of the chosen architecture or tools. We will start with data masking. Data masking is a technique used to protect sensitive information by replacing it with fictional yet realistic data. The goal is to ensure that the masked data remains usable for testing, development, or analysis while safeguarding the original data from unauthorized access. As you can see from the graphic on the slide, masking involves changing data in such a way that the data remains intact but is not visible for unauthorized users. This way, the privacy of personal information can be safeguarded. Data minimization is a fundamental principle of data privacy that emphasizes the collection, storage, and processing of only the minimum amount of personal data necessary to achieve a specific purpose. This principle is enshrined in various data protection regulations, such as the General Data Protection Regulation in the European Union, which mandates that personal data should be adequate, relevant, and limited to what is necessary for the intended purposes. By adhering to data minimization, organizations can reduce the risk of data breaches, ensure compliance with legal requirements, and foster greater trust with their users. A closely related principle of data minimization is anonymization and pseudonymization. Data anonymization and pseudonymization are critical techniques used in data privacy to protect personal information while still allowing for its use in analysis and processing. These methods help organizations comply with data protection regulations and mitigate the risk of data breaches. Data anonymization involves transforming personal data in such a way that the individuals to whom the data pertains can no longer be identified, either directly or indirectly. The goal is to irreversibly prevent re-identification. Pseudonymization, on the other hand, replaces identifiable information within a data set with artificial identifiers or pseudonyms. Unlike anonymization, pseudonymization is reversible if the correct re-identification key or process is applied. Data encryption is a crucial method for safeguarding sensitive information. It converts it into an unreadable format that can only be deciphered with a decryption key. This technique ensures that even if data is intercepted or accessed without authorization, it remains unintelligible and secure. At its core, data encryption involves the use of algorithms to transform plaintext into ciphertext. This transformation is achieved using an encryption key, which is a string of characters used in the encryption algorithm to scramble the data. To convert the ciphertext back into readable plaintext, a corresponding decryption key is required. As you can imagine, encryption is a fundamental technique in data engineering, especially when constructing data pipelines that carry sensitive information. The last major privacy technique that we will discuss in this module is access controls. Access controls are security mechanisms that regulate who or what can view or use resources in a computing environment. In the context of data engineering, access controls are critical for protecting sensitive data and ensuring that only authorized users can access, modify, or delete data. Implementing robust access controls helps prevent data breaches, misuse of information, and unauthorized access to sensitive data, thereby maintaining data integrity, confidentiality, and availability.